Hi, everybody. So in this section, we're going to look at correlation, which basically just means a relationship. So we're looking to see if two variables have a relationship together. So in this section, we will study how to describe what type of relationship or correlation exists between two quantitative variables and how to determine whether the correlation is significant. Now, a correlation, like I said, is just a relationship between two variables. The data can be represented by ordered pairs x, y. X is your independent variable and y is your dependent variable. Now, back in section 2.2, we did learn that the graph of ordered pairs is called a scatter plot. So if you need to go back and review section 2.2, please do. But a scatter plot is basically just plotting the different points on the graph and not connecting them with a line. So we're just graphing each pair of points as one single point on the graph. And a scatter plot is used to determine whether a correlation exists between two variables. Now, for our sake, we're going to focus on straight line relationships, so linear or straight line correlations. But there are a lot of different kinds of relationships between variables. They don't have to all be linear. They could be more U-shaped or look like a trig function, like a sine or cosine curve. They could be exponential or logarithmic in shape. So again, for our purposes, we're going to focus on straight line relationships, so linear correlation here, but do know that there are lots of other different types of patterns that we can see with graphs. So here you have examples of 4 different scatter plots. And scatter plots are great. It's usually the first step in trying to analyze two quantitative data items like this to see if there is a relationship. So we will often graph them first. We'll organize them in a table and graph them before we start doing a lot of computations. And that way we kind of get an idea of if there is a pattern to start. So if you look at something like this and see a scatter plot like this, you can see a clear, almost decreasing line cutting right through that data. So it almost looks like a line. It just obviously a little bit spread out, but you have a decreasing line here, and that is a negative linear correlation. So think back to your algebra classes. When you have a decreasing line, right, your slope was negative. So you have a negative correlation here. If your scatter plot looks like this, so it looks almost like a line going upward or increasing, then you have a positive linear correlation. So again, the slope will be positive of that line. There's other kinds of correlation too. So clearly here, there's a definite pattern to this data. It looks like an upside down U. So this is probably some kind of quadratic correlation here. So there is a pattern that clearly exists, but it's nonlinear. So again, for our purposes, at this point, we're just going to say nonlinear, and we're not going to take it any further than that. But there are a lot of different other correlations that we can have. And then in this example here, if your data doesn't seem to have any pattern at all, then there's no correlation. So there's really no way that these two variables seem to be related to each other, at least based on the sample set that we have. All right, so the first couple examples are just on constructing a scatter plot. So in this example here, an economist wants to determine whether there is a linear relationship between a country's gross domestic product and carbon dioxide emissions. The data are shown in the table on the left, and we're going to display that data in a scatter plot. So one thing you want to remember from scatter plots is your x value or your independent variable is going to go on the horizontal axis. Your y value or your dependent variable is going to go on the vertical axis. You want to use consistent spacing here, going in both directions. And again, we typically do want to start at 0 unless there's a big reason why we shouldn't. But we want our data to be nicely spaced and to be representative. So we do want to be careful with our spacing. Now, each of these points represents one of these points here. So for instance, this first horizontal piece is actually the point 1.8, 604.4. So if you look on the graph here, that looks like it's probably around, let's see, 1.8 is close to 2, 604 is close to 600. So it would be this point right here. So each of these pairs of data corresponds to one point on our graph. So each of these pairs here, again, corresponds to 1 point on our graph. And that's what we do. We just graph those points individually. We don't connect them, and that is our scatter plot. Now, if you look here, it does seem to be some sort of positive correlation. Again, it's not perfect. Real-world data is never perfect. We also have a very small sample size here, so it probably would be helpful to have more data. But you can kind of see here, it does seem to be that there is a positive correlation here. It looks like it's leading towards linear between the variables. So there does seem to be some sort of relationship here, and as the GDP increases, emissions also seems to be increasing. Here's another example, and again, I did provide the solutions just because obviously drawing scatter plots takes a long time if you're doing it by hand. So here, a student conducts a study to determine whether there is a linear relationship between the number of hours a student exercises each week and the student's grade point average. The data are shown in the table below, and then we're going to display this in a scatter plot. So they're letting X be the independent variable and GPA be the dependent variable. So I guess they're kind of looking at if there's any correlation between more exercise maybe increases GPA or maybe it decreases GPA because you're spending less time studying. We don't know. So that's what they're looking at here. So the hours of exercise are on the x-axis. The GPA is on the y-axis. You can see our spacing is nicely done here in both directions. Remember, GPA is between 0 and 4, so that's why the spacing is a little bit more, done with fractions instead, whereas our hours of exercise are pretty spread out, so we're going from 2 to 18 there for our tick marks. And again, each of these points represents one value or one data point. So for instance, here, this person has 0 hours of exercise and their GPA is 3.9. So you can see that point is right here. Or let's look at one more. So this person has 6 hours of exercise and their GPA is 2.5. So that would be this point right here. Okay. Now we can do our graphs by hand, or we can also graph these in our graphing calculator, for instance. And you can do them on Excel too. So there's lots of different ways and technologies that you can graph. So I'm just going to do the calculator as an example. And I think I'll use this first example here for my data set. So if you do want to do a scatter plot on your calculator, then the first thing you need to do is enter your data. So we're going to press Stat and then Edit. Let me just put this down a little bit. Okay. And then what you want to do is in L1, you want to put your X values. And in L2, you want to put your Y values. So you are going to separate these out. So I'm just going to go right down the line here. You do want to make sure the pairs stay together. So that is important that your pairs are staying together here. So I'm going to just stay in order. So I have 1.8 as my first X value, 1.3, 2.4, 1.5, 3.9, 2.1, 0.9, 1.4, 3.0, and 4.6. All right, I'm just going to double check those because we all know that a little mistake can make a big difference in our answers here. And then I'm going to do my L2. So I have 604.4, 434.2, 544.0, 370.4. All right, 742.3, 340.5. So it does take a little bit of time. 232.0, 262.3, 441.9, and finally 1,157.7. Okay, so I have all my data entered. And then what we're going to do is we're actually going to go to Stat Plot. So you're going to hit the second button and then Y equals to get Stat Plot. And you do want to make sure you adjust your plot. So notice that my graph is selected, so it's green on the app, or if you're not using the app, you just want to make sure it's selected. And you can on the app, just touch screen it and you can go through the different types of graphs here. We've done histograms before and box plots and things. So you want the one that looks like a scatter plot. You can choose which kind of symbol you like for that. And then you do want to make sure that your X list says L1 and your Y list says L2. All right, I'm just going to turn off my other graphs for a second so I can make sure I just have one graph selected. And then you're going to hit the graph button. All right, so we're going to select the scatter plot image, and you want to make sure your X's are L1 and your Y's are L2. We're going to then hit graph. And then if you can't see the graph, like I can't here, then you do want to go to your zoom button and you want to do zoom. And you want to make sure you do the one that says zoom stat. And then you should be able to see that scatter plot. So you can see all that scatter plot all right here. It's a little hard to see on the camera, but you do have these little green dots here. I'm just kind of trying to point them out with my pencil. So you can see that they were graphed. And the Y values are pretty large, so that's why you have some pretty large Y values there. But our X values were pretty small. So there's your scatter plot. So that's one way you can use technology here if you want to kind of see those scatter plots first. You're going to notice on a lot of the homework, you're just going to be choosing the correct scatter plot. So that's pretty easy to do. You can kind of just check the points and make sure that you find the ones that line up correctly. But if you want to use technology, like I said, you can do that on your calculator. Another nice calculator feature, just as a side note, one of my favorite online calculators is called Desmos. So if you need an online calculator, this is actually really great too, just to graph XY plane stuff. So you can actually input this in Desmos as well, just input the individual points and it will also plot them all for you. So if you're not using the graphing calculator, then this online is a great graphing calculator as well. All right. And just as a side note, I did skip a couple of these examples in our lecture, so you can go in and see example 3 in your text for another example of a scatter plot, but I thought the 2 examples were good here.